Hello, everyone. Today we'll be giving a presentation about our Boatmap Pro database project for the University of Nebraska at Lincoln. I'm John Ernest, and Hunter Dorhout is joining me today to talk about this awesome software.
Yeah, so first we'll get started with a few of the motivations and goals um, that we had in our mind entering this project. So the inspiration for this uh, project, I am an avid fisherman and boat user, and obviously we're computer engineers. So kind of the intersection of that, the technology that's equipped on boats and fish finders and GPS tracking. So we wanted to do something with that, something similar to maybe like an air traffic controlling software where we're able to keep track of moving vehicles. And we also wanted to use MLPQ constraint databases, obviously, and relational databases. So those were kind of the things that we had in our head when we were deciding on what exactly Boatmap Pro was going to do.
And we also had to think of, who would be consuming this application that we've thought of. The, most direct one is probably fishermen who want to see, how certain hot spots on the lake where they were catching fish, and being able to retrace that path in case they want to fish in that area again. That can be super useful. Sailors can also use this to make sure, they know where they travel across the lake, who owns what boat and stuff. And that sort of also brings in the lake officials who they can see who is traveling on the lake at a certain time, how many boats are there, where they're currently at, things like that. Lake officials might need to know that for who knows what type of reasons. But
So, what exactly does Boatmap Pro offer? What are the services that we provide to our customers? So, the sort of elevator speech of Boatmap Pro is to provide a reliable, precise solution for tracking boat trips via use of periodic geographical coordinates. So the assumption here is that boats and customers who want to implement our software have a boat that is capable of, is equipped with GPS technology that's capable of recording a latitude and longitude at a periodic time interval. So let's say they might have a Garmin fish finder that has the ability to every 30 seconds take their latitude and longitude and record that. So with that information, we want to provide analysis capabilities on prior trips. So things like visualizing tracks and knowing where they caught fish. And then we also want to provide the ability to visualize both lakes and the tracks that the boats followed on
so now we can start talking about the design overview of our project. So what we see here is the entity relationship diagram that we came up with. So if we look up at the top right, this fish entity set is really just there to provide more specific information about, the fish. So like the length, the species. We can even add more to this, if for future work, things like that. And we also have another similar type of information table with this boat entity set right here. So instead, it just has more information about the boat, like who owns it, the length of the boat, name of the boat, things like that. So this fish mapper uh, relationship between boat location and fish, that's important there so that we know at what time and at what trip the certain fish was caught. And we can map that with the certain boat location to get, the certain coordinates of the boat as well. And this boat location entity set right here is a constraint representation of the path that the boat took across the lake. So we have X coordinates, Y coordinates, and time with that. And that time is used to determine, what the certain X and Y coordinates are at a specific given moment. So we also have this trip relationship, which is really what we use to map this boat location and the lake that it's on. And it also has some extra information, like the name of the boat, the date, the captain of that boat, things like that. So this lake right here is another constraint entity set. And this really just sort of a geographic representation of the lake in MLPQ. So it has certain X coordinates, Y coordinates, and, certain like, depending on what we use, which in our project we use the Pawnee Lake.
Yeah, so then we went ahead and transformed that ER relationship diagram into a database schema with a total of 6 tables. You can see here we have fish, again, like John said, just the length and species, fish mapper, which maps the fish to the boat location, the trip, boat, and lake. So all very similar to as was shown in the ER diagram.
So some of the challenges that we ran into were specifically that boat location pathing that took the most time for our project. Being able to incorporate, spatiotemporal data in with just, normal X and Y coordinates, that took us a bit. That also, comes in with generating these constraints for these databases. The boat location identifiers were also, a challenge that we ran into. And we also ended up having to deal with a lot of data points, especially for that boat, location path, the path that the boat took. That has a lot of like separate times in the piecewise, graphs that we ended up having to generate for that. So you have to be careful about how fast, you want to animate that boat's path in MLPQ. And you'll see that a bit later in our project.
Yeah, so we'll go ahead and discuss some of our data sources here. So our main data source and kind of example lake that we worked off of was this PNG image of Pawnee Lake just outside of Lincoln. We retrieved this from Google Maps. And then in order to create an MLPQ representation, a constraint database representation of this lake, we used the I2V2C MATLAB script and just clicked around the perimeter of the lake in order to get a mathematical constraint representation of it. And then as far as simulating the geographical coordinates that would be gathered by a boat, we used a modified version of a MATLAB script in order to gather the X and Y coordinates of the mouse clicks as we clicked along a theoretical path that a boat might take while fishing this lake. It should be noted probably that while we do refer to latitude and longitude throughout the course of this project, our test data is actually just simple coordinates that represent the X and Y pixels of the image itself as gathered by MATLAB. This doesn't in any way like invalidate our process at all, as everything would translate perfectly. If we did have real latitudes and longitudes, they're simply doubles, negative and positive. So that should be noted, but yeah, that was kind of our main data sources that we used.
So the image that we see here is just a little sample of the data that we used for our boat location. So this column A right here is just X coordinates that we sampled using those MATLAB scripts. B, that column is our Y coordinates, and C right here is the certain time that we sampled the X and Y coordinate, and D is the type of fish that we caught. So
now we'll go ahead and get into a little bit of the meat of the project, so some data transformations. So in order to transform our XY coordinates into some meaningful spatial temporal data, we used a couple different methodologies. So we used the P-line script to generate the linear representations of movement between point A and B in the sequence of linear points, as well as the I2V2C script. So then we also, in order to be able to classify this motion, not only a linear interpolation of it, but a temporal representation of it. So we had to add T to the interpolations. And we did this essentially using a moving points model. So we modeled the movement from point A to point B. We modeled the movement in the x direction and split that equally over the time interval represented, and the same thing in the y axis. So what you'll end up seeing on the next slide is our boat location table, and that has a function for the movement in the x direction as a function of t, and the movement in the y direction as a function of t. So it's a simple moving points database representation, as discussed earlier in the class. And we used a link pad, so essentially a C# terminal with a C# script in order to generate this MLPQ file. So we did all of our interpolation and printing and formatting of the boat location table in this MLPQ, in LinkPad using C#, just because that's the most familiar tool that we're with.
So what we see here is sort of the results that we got from our pretty cool link script. So right here, this is the MLPQ file that we generated for the boat location. And if you can look there, you can see, you know, how we generate our X and Y values based upon the time, you know, of the boat. So we got this by reading boat data coordinates from a CSV, and then we created an interpolation equation using those points that we just read. We also added time to that. And then, you know, once we got that equation, we formatted everything for MLPQ syntax, and we just wrote it to, you know, a simple file. So
we'll go over a couple demonstrations here. This first demonstration actually accounts for the extra credit portion of our project, which is the visualization of a moving object over time. So let me open this up here. You'll see here on the screen in black, this is the MLPQ constraint representation of the upper half of Pawnee Lake. And it's difficult to see because of the small nature of a moving point. But right up here, there's a little white point, which is representing our boat as at the initial t=0 value. And we'll go ahead and click play here, and you'll see that moving that point. When we click play, we'll go ahead and move along the path that we designated as a path that a boat might take to fish. So really, this goes to show the comprehensive nature of our interpolation. So we took what were essentially piecewise points that just represented, you know, I was here and then I was here. And with our linear interpolation that takes into account time, we are able to generate the ability to create a smooth path from piecewise points. So yeah, that is one of the coolest functionalities of our project. Keep going.
So now these are some of the queries and functions that we had. So, you know, the main one that we had is trying to figure out what a boat's coordinates was at a certain time. So if you see here on the left, this is our MLPQ SQL syntax. You just type in any time you want really, and then the output will pop out the X and Y coordinates of that boat at that time, which those X and Y coordinates are, you know, they're in the spirit of latitude and longitude.
Another thing that our customers might find super useful is how many fish were caught on a particular trip. So you can see here, given the ID of a trip, which corresponds to, you know, a date like captive boat pair or tuple, I guess, then we're able to just query on the fish mapper table and find the number of fish that were caught on a particular trip. So again, as John had mentioned before, this can be super useful, especially, you know, fishermen that do a lot of fishing. You know, you can't necessarily remember all the days sort of run together. So to be able to have this exact historical representation of fish caught kind of opens up a lot of opportunities for fishermen and biologists and all that sector.
Yeah, so we can also figure out, you know, which specific boat belongs to what owner. You know, maybe an owner owns certain, you know, a certain number of boats like the one we see here. So all you have to do is just query, the search and owner name that we have, and the output will pop out all of the boats that are in our database that have Hunter Dorhout as that owner.
So these are just a couple of the functionalities that Boatmap Pro offers, but definitely not limited to these analyses. So we'll go ahead and talk a little bit about our conclusions and some possible future work. So conclusion, we were successful in developing a fish finding and boat tracking system, i.e. Boatmap Pro. And through that, we learned a lot more about linear approximations and interpolations, and specifically how to incorporate time into those interpolations to create a true spatial temporal moving points database representation given the data that we had. And we definitely learned a lot more about MLPQ, specifically when it comes to the temporal functions of that program and using that to animate objects.
So some future work that can be done are, adding more boats, because usually lake has a lot more than just a singular boat that's traveling across it. You can also add more lakes, that would be pretty nice. And to make this actually be, like use real world data and stuff, one of the more important things that we can do is using actual latitude and longitude coordinates for the boat, so that it's not just some, representation of just a random X and Y value. And we can also fill out some more of our info tables with more, fish data, more data on boats, things like that.
We appreciate you taking the time to listen. Thank you.